Hello everyone, and today I'm going to talk about the Sudoku solving algorithm. This is the content, and I will talk about the history and what is Sudoku and the complexity analysis and the conclusion. First, the history. The history of Sudoku. The origin form of the Sudoku is a Latin square, and it is like this. Okay, so each row and each line only contains 1 to 3 numbers and doesn't exist twice. And the modern Sudoku first occurred in 1984 on a newspaper in Japan, and it soon spread across the world with many kinds like this. This is called the puzzle Sudoku, and each color can only contain one number one time. So the second part, the Sudoku. So what is a Sudoku? It contains 81 cells in a 9x9 grid like this, and each number from 1 to 9 can only occur one in each row and each column and each box. So as you can see, there are some blanks you need to fill in. So how to solve a Sudoku? So this is the original Sudoku, and I can input it into my computer, and then like this, the blank, I will use dot to represent it. And then I can use my computer to solve the problem. And this is a legal solution like this. Okay, so how to solve a Sudoku? We can use the backtracking algorithm and the DFS and brute force. And I will talk about these three methods later. Okay, so this is the basic concept of my program. And first, you need to scan the Sudoku, and then you need to get the empty space, like where is empty, and you need to fill some number inside. And I will get the candidate, like what number can be put into the space. And then I will check whether it is legal to put the number inside. And then I will fill this space, and I will do it again until there is no empty space anymore. And that means that I have filled all the blanks in it, and I can print out the answer. So for example, here are 4x4 Sudoku, and I will play it once. We can put 4 in it because here is 1, 2, 3, and this only can be 4. And then second, I will place 3 into the block. 1, 2, 3. Okay, you can put 3 inside. So here, there are 3, and I see 1 and 3. So you can put 2 and 4 inside this blank. So I will put 2 inside it, and then I will see that if this is 2, there's 1, 2, 3, and 4 must to be put in here. But in this row, there are 4 here. So it means that it couldn't be 4. So I will backtracking to put 4 inside this blank. And then I will put 2 inside this. And then it is obvious to put 2 in it, and 3 and 1. And you have solved this Sudoku. So here are some basic concepts of the program. First, you need to scan and print the Sudoku. And second, you need to find the candidates like this. You need to find what numbers can be put inside this blank. So you need to find the candidates, and you need to find the next empty space, and then solving the function. First, the print and scan function. So this is the print function, and this is the scan function. And this is the find candidate function, and the function will check each row and each column and the 3x3 box, and it will return the numbers that it can be put inside the space. For example, here, if I want to put number inside, here are 1, 2, 3, and 4. So first, I will look at the row. As you can see, 3 is here, so you cannot put 3 inside it. And the second one is column. I will check the column, and I will find that 1 is not capable to put inside. So I will cross 2. And the function will return, 3x3 box, and 1 and 3 is cannot put inside, so cross. And the function will return 2 and 4. So the function will try 2. If 2 cannot put inside, that means you need to put 4 inside. So the next function is find next empty space. So it will return the index of the next empty space. Okay, so start solving. The method that's used inside is the recursive function. It means that the function calls by itself, like use DFS right here, and it will call the function itself. So it will do the same thing with another space, and it will do the function until the function finds a solution. Okay, next, there is the complexity analysis. So we are curious about how long did the program need to compute all the solutions. So the speed, a normal computer can do 1 to the power of 8 calculations per second. And the legal solution, I Googled it, and it has 6 times the 10 to the power of 21 solutions. The legal solutions to a 9 times 9 Sudoku. But I have tested my program can calculate one solution in average within 1 second. And here are so many solutions, and I want to know how exactly the time needs to print all the solutions. So the solutions are here, and here's the 10 to the power of 8 is the computer can do the calculation in 1 second. So it is equals to 6 times the 10 to the 13 seconds. So you need this long to print all the solutions it has. So it is as long as 2 billion years, and it is almost equal to the length of the human history. So it is almost impossible to print all the solutions. Okay, number 4, the conclusion. The backtracking method and can also be used to solve the 8-queen problem. If you are interested in how to solve this problem, you can ask me. It is for short. It is 8 times 8 chessboard, and there are 8 queens, and you need to put 8 queens on the board, and the queens cannot eat or be eaten by each other. Like this is a legal solution. And there are many algorithms for you to discover. And that is my presentation. Thank you for listening.